Okay, so just going to do a quick one going over radians and degrees and kind of converting between and that kind of idea. So it was kind of the first section in the book. So we've looked at kind of degrees, I suppose normally is what you'd be used to working with. So like 30 degrees, 90 degrees, 170, all of that, just examples there. But what we can do now is we can write our angles using this new unit, and the unit's called radians. And the definition of a radian is this here. So one radian is defined as the angle for which the arc length is equal to the radius. Now what does that mean, I suppose? Well, it means that if I have kind of a segment like that of a circle, so kind of a part of a circle here, this angle, if this angle is 1 radian, then that is the angle for which this length here, the arc length, is the same as the radius length. So it's whatever that angle needs to be for the arc length and the radians to be the same. So if we remember as well, then the circumference has a length of 2 pi r, so then that means that the full circle is 2 pi radians. And we can kind of use that then in our conversion, because what that means, of course, is that 2 pi radians is 360 degrees, and then indeed pi radians is 180 degrees. So if we're trying to convert between radians and degrees, the quickest way to do it is to go from radians to degrees, we multiply by 180 over pi, and to go from degrees to radians, we multiply by pi over 180. So obviously it's quicker to use the pi and the 180 than the 2 pi and the 360. So if we're looking at these examples here, we're asked to convert the following to either radians or degrees. Okay, so we're going to start with the 5 pi over 18. So the 5 pi over 18 currently is radians, so let's just kind of note down that pi is equal to 180 degrees. So pi radians is 180 degrees. So 5 pi over 18 is equal to, so let's multiply the other side by the same thing, so 180 by 5 pi over 18. Or not 5 pi over 18, sorry, just 5 over 18. Ooh, what's happened? Getting our answer a bit early there. So let's go back again. There we go. It's just 5 over 18. And working that one out for us then, we get an answer of 50. So 50 degrees. Okay, we can use then as well what we've kind of said there. If I'm going from radians to degrees, I can multiply by 180 over pi. And what do I get here? Well, 11 over 6 multiplied by 180 gives me 330 degrees. Okay, same thing for the next one. To go from degrees to radians, I multiply by pi over 180. And what does that give me? So that gives me pi over 4. And then same thing for the last one, 432, again multiply by pi over 180, and we get 12 pi over 5. Okay, so just keeping those kind of consistent, I suppose, and you're following the conversion that we have there at the top, so the 180 over pi and the pi over 180. And you can see in the first one that even if you can't remember exactly which way those go, you can kind of work it out kind of more methodically with the first one. If you just set out what is 1 radian equal to, or what is pi radians equal to, and you can kind of go from there then. So looking then at the arc length and the area of a sector. So in a circle, an arc is a portion of the circumference, and a sector is the whole kind of pizza slice, if you like, that's between 2 radii and the arc. And we have a formula for finding the arc length and the area of the sector. And you would have seen one of these formulas at junior cert, and that would have been the bottom one here, which was for degrees. What we're looking at now is a slightly different formula when the angle's in radians. And we can see it there. So if L is the arc length there, then if we have our angle in radians, our arc length is going to be that angle multiplied by the radius. And the same thing then goes for the area. The area of that sector would be a half r squared theta, the angle in radians. So let's see how that kind of works in practice then. So for this example, we're finding the length of the arc AB. So from our formula, which as we've kind of said before, you start off by always writing out your formula, keep everything kind of consistent. So the radius is 8, my angle is pi over 3. Okay, and following that through, we get an answer of obviously 8 pi over 3, and we can work that out exactly, which is 8.378 centimeters. Okay, so let's go with centimeters, and then find the area is a half r squared theta. So a half by 8 squared by theta, which is pi over 3. And following that through, 1 over 2 by 8 squared by pi over 3. And I get 32 pi over 3, which is equal to approximately 33.51 centimeters squared. So that gives me the area of the shaded blue part here, the sector that I have there. So before we look at an exam question, just to kind of quickly go back over, and I know I skipped over it there just when we were looking at it, but just to go over on our calculator then, if we were working with our calculator and we come to a question where the answer or the angle is given to us in radians, then we need to make sure that our calculator is set to radians. And how we know that is at the top of your calculator, you'll see there's a small set of squares, and in them they have D, or, and G, okay? And you can only kind of see one of them lit up at a time, and that will be whichever mode your calculator is set in. So if your calculator is set in degrees, then the D will be kind of lit up, and if it's set in radians, then it'll be the or. Now the G is for, it stands for gradians, and we're not going to use those. So just degree and radians. To actually change it, what you need to do is you're going to press Shift, and you're going to press the menu or the setup button. Okay, so it says menu, and then in part of the shift settings of it, I suppose it says setup. Okay, so by pressing shift, we're accessing that setup part. So shift and then that menu or setup button. Then you're going to press number 2, which is angle unit, and then we pick either degrees or radians, depending on which we want. And there's ways of kind of spotting which one your calculator is set to. So if you get an answer that's maybe a minus or that is really particularly small, it might mean that you've accidentally used your calculator in radians when working with degrees. But it's really, really important that when you start a question, you see what angle, what units your angle is in, because it can change across questions and across the paper. Obviously it can depend how each question is formatted and each question is laid out, but it's important that you know at the start of the question which angle unit you're going to be using, because that's going to be important when you're using your calculator. So kind of seeing that, I suppose, in practice, we'll see that in this exam question. So a cattle feeding trough of uniform cross section and 2.5 meters in length is shown in this figure, and the front is a segment ABC. So we can see there kind of they're mapping this front part here with this part here. Okay, and they've added in some extra lines, and where those come in is that the front of the trough is actually a segment of a circle of radius 90 centimeters. So they're telling us that that front kind of semicircular part is actually a segment of a bigger circle, okay, for working out our measurements. And the height of the trough then is 30 centimeters. So the first part asks us to find AD. Find the line AD. So AD is this line here. And in order to find that one, we need to use some simple enough points, I suppose. This part here would be the radius of the circle, which we already know is 90 degrees. And if this part here is 30 degrees, well then that's going to mean that my point here, OD, if I draw that in with another colour, this part here would be 60 centimetres. Sorry, I've been saying degrees, centimetres obviously. So that would be 60 centimetres. If we take this triangle maybe out to the side here, so OAD with my right angle, this is 60, this is 90, and AD is what we're looking for. So we can use Pythagoras then. So 90 squared is equal to 60 squared plus AD squared. And we can follow this through again, I suppose, and work it out exactly. So 8,100 is 60 squared, which is 3,600 plus AD squared. And we get that AD squared is 4,500. So AD is the square root of that, and we get 30 root 5, which is the form that they asked us to give our answer in. So surd form A root B. Now we need to find the angle DOA, and the angle DOA is this angle up the top here. And similarly in our little triangle that we drew on the side, it's that angle up there. And to find that angle, we can use our trig ratios. Is probably the easiest way to go with this one. So if we're looking at the triangle up here, well, we could use, obviously this is the opposite side, this is my adjacent, and this is my hypotenuse. So maybe we'll stick with the ones that they've given us already, the sides that they've given us. So we'll go adjacent over hypotenuse, and that's cos, obviously. And then that means that my angle DOA is the cos inverse of that. And we're asked to give our answer in radians, so we need to make sure that our calculator is set to radians before we compute this one, before we work it out in our calculator. And working that out, we get a value of, corrected 2 decimal places, 0.84 radians. 0.84 radians. The last part now is asking us to find the area of the segment ABC. And we can see that that segment is part of a bigger triangle. Or do we have the full segment, I suppose, the full sector of the circle? The segment there then is the part of the sector without that triangular part. So if we could work out the area of the triangular part, so that whole part here, if we could work out the area of that whole part, and then work out the area of the full sector, we could work out the area of the yellow part by kind of subtracting those two values. So let's work that out. So area of the sector, well, from our formula from earlier, that's pi r squared theta. Now we have to think for a second, what is my angle? Well, my angle is going to be the angle here, this angle that I've put in black here, and that's going to be twice the angle that we just worked out, so 1.68 radians. My radius is still 90, so 90 squared by 1.68. I'm working out my answer. I get an answer of 6804 centimeters squared. Then to find the area of the triangle then. Okay, so what we could do is we could work out the area of the triangle AOD. Okay, AOD. So if we were to work out the area of that triangle, given that we know what the angle is, we can use our formula half AB sine C. And matching that up with what I have here, I'm going to have to use the 90 and 60 and then the angle that we have. So half 90, 60, and then sine of my angle that we have, which was in radians, so sine of 0.84. Working that all out, then we can type that into our calculator, and we get a value of 2010.536. Okay, that obviously is only half of the full blue triangle, so I need to multiply that by 2 to get the whole triangle, and that gives me a value of 4021.07 centimeters squared. And that means the area of the segment is by subtracting this area, which is the blue triangular part, from the total area, which we got was this part up here. So 6,804 minus 4021.07, and that's going to give me an answer of approximately 2782.93 centimeters squared. And we're asked to give our answer in meters squared corrected to 2 decimal places. So I'm presuming that's centimeters squared. Or sorry, meters squared corrected to 2 decimal places. So to 2 decimal places, we have it in 2 decimal places there. 2782.93 centimeters squared. Okay. So the key thing with this one's going to be making sure that we have all the key points involved in the question, okay, or the radians, making sure that we're paying attention to the angles in the question is what I mean to say. So making sure that when we're looking at the question, and if they give us the angle in radians, that we're definitely using radians. If they give it in degrees, that we're definitely using degrees. That's an easy way to get the whole question wrong, is by having your calculator in the wrong mode, or not recognizing that they want the answer in radians or they want the answer in degrees. So that's the first thing that you should kind of highlight in the question. And then anything from that you can kind of work with, and you can follow it through. And as we saw there, we can still use all our formulas the same way. We can use our angle one, we can still work with Pythagoras, we can use our trig ratios, but we just have to make sure that we have our calculator in the right form, and that if our answer is in radians, that we're writing down that answer is in radians. So just keeping that consistency, I suppose, to it.